So we're moving on from simplifying rational expressions, multiplying rational expressions, and dividing rational expressions into adding and subtracting rational expressions. So as always, don't forget these relate to numbers. If I asked you to add 3 halves plus 1 half, you'd have your common denominator of 2, and then you'd have 3 of the halves and 1 more half, so you have 4 halves, and then that would simplify to 2. So to add fractions, you need a common denominator. They need to be out of a common piece so that you can add the numerators together. And the same rule applies for expressions. So if we've got objective 1, which is rationalize or adding and subtracting with the same denominator, step 1 is that if the denominators are the same, just add and subtract the numerators. Place the result over a common denominator and then simplify. And then objective 2 will move on to when I think even in objective 1, we move on to when the denominators are different. Well, the first thing you have to do is find a common denominator and then write your expressions with the lowest common denominator, add and subtract the numerators, place your result over the common denominator, and simplify. So let's start with common denominators. So notice how we have 3 terms here, and they all have a denominator of y. So what I like to do is say, hey, you know what? These all have a common denominator of y. So on the top, you'd have 5 plus 3 minus 7. So you have 8 minus 7, which is 1 over y. This one, same thing. You have that common denominator. So I'm going to rewrite it with that common denominator. And I'm going to say on the top, you have 2x, take away. Now you're taking away this whole numerator. So this is why this step's really important, is that when it's a subtraction, you have to make sure that you distribute the minus sign through the whole numerator. So this would be 2x minus x plus 1 over x plus 1. Then we get, I'm just going to go up here, we get 2x minus x is x plus 1 over x plus 1. Now, because these are the same, you can say x plus 1 divided by itself is 1. All right, moving on. So here we go. We have another common denominator. So I'm going to write everything over r squared minus t squared. And then on the numerator, I have r plus t. Now remember, step number 1 was to do the adding and place your result over the common denominator. But don't forget this step. You're always going to look to see, after you've added, can you simplify? Well, hopefully you're starting to see these different factorings that jump out at you. Anytime I see an exponent, I think, I should probably factor this. So this is a difference of squares, so it'd be r minus t, r plus t, and then this is a monomial divided by a monomial, so I'm allowed to simplify my factors, and I end up with 1 over r minus t. All right, same thing over here. I have a common denominator. That common denominator is x squared plus 3x minus 18. In the numerator, I'm going to have 6 plus x. Now I want to look to see if I can simplify. We're back to chapter 6.1, right? Factor before you simplify. So in the denominator, I have a trinomial. I'm going to put an x, I'm going to put an x. I'm looking for 2 numbers that multiply to give me negative 18 and add to give me positive 3. So that's going to be positive 6 and negative 3. I knew I made a mistake because I'm adding to get positive 3, so my bigger number had to be positive. And then I have a 6 plus x on the top. Now I have a common factor, so I can do 6 plus x over x plus 6 is the same. If I wrote them in a different order, they'd still be the same, and I can say that it's 1. So this would simplify to 1 over x minus 3. All right, so that is simplifying when the denominator is the same, and there's a bunch of questions in your homework with a common denominator, so I'm going to stop there. I'm going to say in your homework you can do anything up to question 21 and then come back and do the next video.